Ultralink processing is a high-capacity, wide-area communication system that's designed for low-power operation, communicating across large geographic areas. Some of the applications our technology is ideally suited for, and applications we're actually working on today with some of the largest customers in the industry include smart grid, being able to remotely detect faults in the distribution grid to speed the repair of communication lines, improve uptime, and reduce cost. Another application example would be that of tracking of people, personnel across military bases or in areas where there's spotty cell phone coverage, such as in downtown locations and basement of buildings where we can track people in real time. Another example are things like remote monitoring of communications devices such as wellheads, oil pipelines, and also new applications that we've just started working on are the monitoring of medical devices for patient safety and patient care in hospitals and home care facilities. The best way to answer that question is with one concrete example that may be a bit extreme, but is a very representative case of sensor networking and utility infrastructure. So think about a distribution grid for electricity, water, and gas that goes through an entire county or city. It could be thousands of square miles, thousands of miles of pipes that go below ground. They're typically below manhole covers, very hard to reach locations, and identifying these leaks and faults is extremely challenging, and wireless can play a part. However, you're not going to be able to do that with a cellular system, as you can't reach below a manhole cover, or use a repeater system. There's no place with which to repeat the signal, so it adds a lot of infrastructure cost and complexity. Whereas just one example, what Ultralink processing can do is cover this vast geographic area with no repeaters, be able to cover thousands of square miles with minimal infrastructure cost, and then have very long battery life, which is required since many of these devices must run for 10 to 15 years on battery to make them cost effective and tolerant to the conditions. So this is an extreme example, but just one application space where it clearly defines our differentiation. Well, cost is a really critical advantage that really has to be well thought out when looking at a wireless networking solution. So if you take the main components that drive total cost of ownership in a network, it's the hardware cost, the endpoint device, the network infrastructure cost, as well as the deployment engineering, integration, as well as operating cost of the network, which could also include license fee spectrum for other technologies. What we bring to the table in terms of this total cost of ownership model are a few points. Number one, many orders of magnitude less network infrastructure cost, simpler to deploy, and is able to operate with very high reliability and free spectrum, which drives a total cost of ownership that's significantly lower than any other radio technology for the applications with which we can target. Big picture really is this machine-to-machine area, sensor networking, or some people call it the Internet of Things, is really now entering explosive growth. And it's a different communications problem, and Ultralink processing and OnRamp is working with some of the key industry vendors and across many of these verticals to help shape the future of these applications. However, we really need partners to adopt our platform. We do not provide the application layer or the end-to-end solution, but really require developers, integrators with which to work to shape these solutions for the future.